Welcome dear students to this session. Dear students, we are going to discuss from class 9 mathematics book chapter 8 quadrilateral part 3. Before going to discuss today's lesson, let's see what we have learnt about quadrilateral till now. We learnt angle sum property of a quadrilateral, that is sum of interior angles of a quadrilateral is 360 degree, and we also learnt about some properties of parallelogram. What is that? A diagonal of a parallelogram divides it into two congruent triangles. So, one diagonal divides a parallelogram into two triangles and those two triangles are congruent. Let us see another property, that is in a parallelogram opposite sides are equal. So, we have two pairs of opposite sides, each pair of opposite sides is equal in a parallelogram. Now, its converse is also true, that is if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Today, we are going to learn something more about parallelogram. Let us state one such property. In a parallelogram, opposite angles are equal. In last class, we learnt that in a parallelogram, opposite sides are equal. Here, we learn that the opposite angles are also equal. So, for that let us have a figure. Here ABCD is a parallelogram. So, our given point is ABCD is a parallelogram. Then what to prove? We have to prove that opposite angles are equal. That is, angle ABC is equal to angle ADC. We have to show, because these two are opposite angles. Let us have another pair of opposite angles. These are angle BAD and angle BCD. So, we can write in two proof part that angle ABC is congruent to angle CDA and angle BCD is congruent to angle DAB. Let us see. Here we need a construction. What is the construction? Draw the diagonal AC. Now, after drawing the diagonal AC, as we know, we have two congruent triangles. See, let us prove it. BC is parallel to AD. As you know, here BC and AD are parallel. And the angle BCA and angle DAC, these two are equal because they are alternate interior angles. Similarly, we have AB is parallel to CD and AC is the transversal. So, other pair of alternate interior angles are angle BAC and angle ACD. So, we can name these equations as equation 1 and 2. Now, let us see. In triangle ABC and ADC, as we discussed, we have two triangles. BCA angle is equal to angle DAC, BAC angle is equal to angle ACD, and AC is equal to CA, that is common side. So, these two triangles are congruent by angle side angle property. Now, if by angle side angle property they are congruent, then we can say that ABC is equal to CDA. Why? This angle ABC is equal to CDA because they are corresponding parts of congruent triangles. So they are equal. So we proved one part of the our theorem. Let's see other part of the theorem. We know that angle BCA is equal to angle DAC and angle SCD is equal to angle BAC. Now you see BCA and SCD, these are two congruent, two adjacent angles. Now let's see, if we add these two equations, then we get angle BCA plus angle SCD is equal to angle DAC plus angle BAC. Now you see, if we see the picture, the figure, you see BCA and ACD, these two are adjacent figures, adjacent angles. So the sum of these two will be same as the angle BCD. So BCA plus ACD will give angle BCD. Similarly, angle DAC and angle BAC, these two are also adjacent angles. So sum of these angles will be the greater angle, that is BAD. So we can write BCD is equal to DAB. This is the second part of our theorem. So as we proved that if a parallelogram is there, then its opposite angles are equal. We must have a converse of this. Means if in a quadrilateral the opposite angles are equal, then the quadrilateral will be a parallelogram. So this is stated as theorem 8.5. If in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Then how to prove it? Let's have a figure that is a quadrilateral. Here ABCD is a quadrilateral. So given that ABCD is a quadrilateral. Now you see ADB and ABC are opposite sides, and it is given that these two angles are equal. Also angle BAD and angle BCD, these two are also opposite angles, and it is given that these two angles are also equal. Now what to prove? We have to prove that ABCD is a parallelogram. Now you see, to prove this to be a parallelogram, we will use the angle sum property and co-interior angle property of parallel lines. Let's see. In quadrilateral ABCD, angle A is equal to angle C as it is given. Angle D is equal to angle B as it is given. So if we add these four, see, these four are interior angles of a quadrilateral. So sum of these four angles is 360 degree. So we can write angle A plus angle B plus angle C plus angle D is equal to 360 degree. Now as we know, A and C are equal, D and B are equal. So we can write angle A plus angle B is equal to angle A plus angle D, because angle A is added in both sides of the second equation. Is you see here it is D and B, and we added angle A on both sides. So we have angle A plus B is equal to angle A plus D, and we know that sum of this will be half of 360 degree as we have equal parts. So 360 degree by 2, that gives 180 degree. So from this line we conclude that angle A plus angle B, sum of these two angles is 180 degree, and sum of angle A and D is also 180 degree. Now recall the co-interior angles in case of parallel lines and transversal. Let's see as the transversal is AB. Here AB is the transversal, AD and BC are parallel lines. So we have angle A and angle B to be co-interior angles. And earlier we proved that angle A plus B is 180 degree. So as co-interior angles are supplementary, so the lines AD and BC are parallel. Now similarly, we can also say that angle A and angle D. So for that, which is the transversal? Here AD is the transversal and AB and CD are the lines and intersects at A and D. So the angle A and angle D are the co-interior angles, and we know that angle A plus D is equal to 180 degree. So as co-interior angles are supplementary, so the lines AB and DC are parallel. As we know that in a quadrilateral, if the opposite sides are parallel, then that quadrilateral is a parallelogram. You see, so we can write in quadrilateral ABCD, each pair of opposite sides is parallel. So ABCD is a parallelogram. By using these two properties, we can solve some questions. Let's see. Here a question is like this. In a parallelogram ABCD, bisectors of angle A and angle C intersect CD and AB at points P and Q respectively. So the figure is like this. Show that APCQ, here the parallelogram, the quadrilateral APCQ is a parallelogram we have to show. So the parallelogram is like this. Here it is given A, B, C, D. Bisector of angle A intersects CD at P, and bisector of angle C intersect AB at Q. So this is given. So we can write here given that in parallelogram ABCD, AP is bisector of angle A intersect DC at P, and bisector of angle C intersect AB at C. Now to prove, we have to prove that APCQ is parallelogram. Now let's see how to prove it. As you know, in parallelogram ABCD, opposite angles are A and C, So we can write angle DAB is equal to angle BCD. And so half of angle DAB is equal to half of angle BCD. As AP is the bisector of angle BAD or DAB, so QAP is half of it. So we can write in place of DAB, we can write angle QAP. Similarly, in place of half BCD, as QCP is half of angle BCD, as QC is the bisector, so we can write QAP is equal to angle QCP. Again, now let's see, CQ is transversal of AB parallel CD. As ABCD is a parallelogram, AB is parallel to CD and QC is the transversal. So we can say this angle Q, BQC, angle BQC is equal to angle QCP. Alternate interior angle. Now you see, so QBC equal to QCP, you see QCP, and again see, if we consider AP as the transversal, AP is transversal of AB parallel to CD, then angle QAP is equal to angle APD. Angle QAP is equal to angle APD. You see QAP is equal to QCP, QCP is equal to BQC, and APD, this QCP is equal to BQC and QAP equal to APD. So this is 1, this is 2 and this is 3. From these 3 we conclude 1, 2 and 3, we conclude that angle APD is equal to angle BQC. So let's see, if we subtract these angles from 180 degree on both sides, we have 180 degree minus angle APD is equal to 180 degree minus BQC. Now you see 180 degree minus APD. The angle APD and APC, they are linear pairs. So 180 degree minus APD gives angle APC. So in place of 180 degree minus angle APD, we can write angle APC. You see, in the next one, 180 degree minus BQC, BQC and AQC, they form the linear pair. So 180 degree minus BQC gives angle AQC. Now see, these two, APC and AQC, are opposite angles of the quadrilateral AQC. And we proved that QAP is equal to QCP, these two are also opposite angles of the quadrilateral AQPC. So we can write as both pair of opposite angles is equal. So ABCD, APCQ is a parallelogram. Let me explain again. Here in this figure, we proved that angle QSP is equal to angle QCP. These two are opposite angles of this quadrilateral. Again, we also proved that angle AQC is equal to angle APC, which are also opposite angles of the quadrilateral AQCP. So as both the pairs of opposite angles equal, so we can say that APCQ is a parallelogram, as we proved the theorem earlier. Let's see another example. Show that the bisectors of angles of a parallelogram form a rectangle. So the figure is like this. ABCD is a parallelogram, AQ and CS are bisectors of angle A and C, DS and BQ are the bisectors of angle B and D. So we have to prove that PQRS is a parallelogram. A parallelogram and a rectangle. So first we will prove it to be a parallelogram, then we will prove it to be a rectangle. The bisector of angle A, bisector of angle D, bisector of angle B, and bisector of angle C. So this point is P, Q, R and S. Now you see, we can prove this to be a rectangle, as we discussed in the previous question, but let's do it independently. Here what is given? In parallelogram ABCD, bisectors of angle A, B, C and D form a quadrilateral PQRS. This is given. So what to prove? We have to prove that PQRS is a rectangle. So what is a rectangle? A rectangle is a quadrilateral which is a parallelogram, and each angle is 90 degree, or one of its angle is 90 degree. Let's see angle B, angle A and angle D. These are co-interior angles, so sum is 180 degree. Let's write the proof. So here we will apply the same co-interior property of parallelogram. So let's write AD is transversal of AB parallel CD, and from this we get angle BAD plus angle ADC is equal to 180 degree because co-interior angles. And if we take half of it, then half BAD plus half ADC is equal to half of 180 degree. That gives half BAD. In place of half BAD we can write DAP. Half BAD is same as PAD. So angle PAD plus angle, similarly half ADC can be written as ADP. So angle ADP. This is equal to half of 180 degree is 90 degree. So in triangle APD triangle, sum of two angles is 90 degree. So third angle must be 90 degree. So we can write in triangle APD, angle APD is equal to 90 degree. Similarly, we can take another pair, that is AB is transversal of AD parallel to BC, ADBC parallel. So angle DAB plus angle ABC, angle DAB plus angle ABC, these are co-interior angles, so sum is 180 degree. Again taking half of it, we have half DAB is plus half ABC is equal to half of 180 degree. Now you see half of DAB, in this case we can take BAP. So angle BAP plus angle half ABC, in place of half ABC we can write ABQ. So let's write here BAQ, and here it is ABQ is equal to 90 degree. BAQ and ABQ are the angles of triangle ABQ. This implies in triangle ABQ, which is the third angle? The third angle is AQB. So angle AQB is equal to 90 degree. Now you see this angle is 90 degree, this angle is 90 degree, and this angle is 90 degree. We can similarly, in similar manner, we can also prove I may write similarly we can show that angle BRC is equal to 90 degree and angle DSC is equal to 90 degree. As you see, BRC is 90 degree, so BRC is equal to angle SRQ is equal to 90 degree. Why these two are equal? They are vertically opposite angles. So this shows that BRC is equal to SRQ, and we have again angle APD is equal to angle SPQ is equal to 90 degree. The reason is same, that is vertically opposite angles. Now you see angle SPQ is equal to angle SRQ. Why? Because both are of measure 90 degree. Again, angle PSR is equal to angle PQR, again due to same reason, that is both are 90 degree. As opposite angles of the quadrilateral PQRS are equal, so PQRS is a parallelogram. So this implies PQRS is a parallelogram with each angle equal to 90 degree. Now you see, as a parallelogram with each angle 90 degree is a rectangle, so we can say that PQRS is a rectangle. So after this line, we will read this line, that is PQRS is a rectangle. So by using angle sum property, we proved another example, that is by using opposite angle property of parallelogram, we proved another question. Let's see another question. In this question, in parallelogram ABCD, X is point on DC such that AD equal to AX. Prove that angle XAB is equal to angle ABC. Now, and also AC is equal to BX. Now, a parallelogram is there. A, B, C, D. From A, we can have a point on BC such that AX equal to AD. If AX equal to AD, then we have this angle ADX is equal to angle AXD. So given in parallelogram ABCD, X is a point on DC such that AD is equal to AX. To prove angle BAX is equal to angle ABC, means we have to prove these angles to be equal, and also we have to prove AC is equal to BX, means this line AC is equal to this line BX. So let's start the proof. Now you see, as ABCD is a parallelogram, the opposite angles are equal, means angle D is equal to angle B. Now you see, AX in AXD triangle AD is equal to AX. This implies angle ADX is equal to angle AXD. This is 1, this is 2. Now AX is transversal of AB parallel to CD. This shows that angle BAX is equal to angle AXD. Now you see, AXD equal to ADX. ADX is ADX. ADX is equal to B. ADX is equal to angle B. So angle B is equal to angle BAX. So from 1, 2 and 3, from 1, 2 and 3, we conclude that angle BAX is equal to angle ABC. You see, angle B is equal to angle D. D is angle equal to X, AXD, and AXD equal to BAX. So angle B is equal to angle BAX. Now using this, we can prove the congruent triangles to show BX equal to AC. In parallelogram, ABCD, AD is equal to BC and AD is equal to AX. This is given. So this shows that BC is equal to AX. Now in triangle ABX and triangle ABC, we have AB equal to BA common side, and we proved that angle BAX is equal to angle ABC. We proved it, and here BC is equal to AX, so we can write AX is equal to BC. So from these three conditions, we conclude that triangle ABX is congruent to BAC. So we can write BX is equal to AC. So this is proved. Dear students, by using another property like opposite angles of a parallelogram are equal, and converse of it, that if a quadrilateral has angles, opposite angles to be equal, then that quadrilateral will be a parallelogram. By using this, we can solve such many problems. Dear students, today we conclude here. Have a good day. Thank you.